We are looking at Surds. So we'll first focus on the three main rules that we use to basically tackle all Surds questions. We'll then look at the subtopics that are involved in Surds and then finish off with some exam style questions at the end. So before we start, let's just make it super clear. Surds is really just another name for roots. Right, as you know, the square root of x is a surd, or the cubed root of 8 is a surd, or the 17th root of a plus b is a surd. Anytime we see this root sign, we're dealing with surds. So let's start off with the three main rules. So the first rule is really just the definition of the square root, right? The square root of anything, let's pick 9 as an example. We know the square root of 9 times the square root of 9. By definition, this must give us 9, right? The square root tells us that the square root times itself gets us the original number, gets us that number inside the square root. It gives us 9 in this case. And the square root of 9 is 3, right? And we can double check this. 3 times 3 does in fact give us 9. And we can generalize this, right? Rather than using just 9 as an example, we can generalize this and we can say the square root of any number times the square root of, again, that same number inside the square root has to get us back to that original number, has to give us a. And that is our first surd rule. The second rule is even a more general version of this, really. It says that if we've got the square root of some number times the square root of a different number, we can smush these two things together and put them both inside the square root. And we could double check this. If we say a and b are the same, right? This also says that root a times root a is the square root of a times a. Well, we know the square root of a times a, well, a times a is just a squared, right? The square root of a squared. Well, if we square something and then immediately square root it, we're just undoing what we just did, right? The square and the square root are complete opposites. It's like, timesing by 5 and dividing by 5. They're complete opposites. What we end up with is our original number. We get back to a. And so, we can kind of, almost relate these two rules together just by replacing b with a. But this is a kind of even more general version of the one above. So this is our first rule. This is our second rule. Our third rule is, again, not too dissimilar to the second rule. If we say rather than root a times root b, I say this is root a times, let's say it's times 1 over root b. Well, if I use this power rule, I'm actually going to say this is the square root of 1 over b. If I use this above power rule, I know this is going to give me the square root of a times 1 over b. Well, we know that a times 1 over b is the exact same as a divided by b, right? 20 times a quarter is 5, or 20 divided by 4 is also 5. So I can either times by 1 over b or I can divide by b. And likewise with this, I can either times by the square root of 1 over b, or I can divide by just the square root of b. And from that very simple substitution, we get our third rule. The third rule says root a divided by root b is root a divided by b. Let's look at adding and subtracting. So this is relatively simple. If we've got, say, as an example, let's say we've got 2 lots of something plus 5 lots of something. Well, we know that's going to give us 7 lots of that same thing, right? This could be apples or oranges or vases or anything we wanted to. Or we could use algebra, right? We could put x in here. We could say 2x plus 5x equals 7x. Or we could even put surds in here. We could say 2 root 3 plus 5 root 3 gives us 7 root 3. This is basically our the way we tackle adding and subtracting, right? If we were to generalize this, a lots of some square root, square root of something, plus some other lot of the square root of that same thing. Or all we do is, in this case, we added 2 and 5 together, right? We add our two numbers together, we do a plus b, and we multiply our original surd, our original root, by that resulting product. So that's basically the rule that we use to tackle adding and subtracting. Right? It doesn't have to be adding. We can put plus or minus in here. This rule still stands. I'm going to take this down here, and we'll look at multiplying and dividing. So there's one trick that we can use to simplify things massively for ourselves. If we look at an example, let's say we've got let's do 2 root 12 times 5 root 3. Let's see what we get with this. Well, 2 root 12, this is just a shorthand way of saying 2 times root 12, right? And we're timesing this by 5 times root 3. All we've got here is we've got 4 terms all timesing each other together in a long line. And when we've got this, it doesn't matter which way around we do this multiplication, right? I could flip this all, and I could go from the right to the left, or from the left to the right, or I could do 5 times root 12 times root 3 times 2. It doesn't matter what order we do things in. So we can use this to our advantage, right? We can simplify things massively, and we can instead group our numbers together. So 2 times 5 at the start. And we can group our surds together at the end. In this case, it's root 12 times root 3. Well, we know 2 times 5 is 10. We know root 12 times root 3. We can use our second surd rule to our advantage. And we can say this is the exact same as the square root of 12 times 3, which is the exact same as the square root, I'll avoid an equal sign there, the exact same as square root of 36, which is the exact same as just 6, isn't it? So what we end up with is just 10 times 6. And that gives us 60. So that's how we can use the very simple principle of rearranging things in a long line of multiplication to our advantage to simplify the problem down, and we end up with a nice number at the end. And the same goes for dividing, right? We can always reorder things in a division as well. Brackets. Let's do another example. Let's say we've got root 5 brackets 2 plus 7 root 5. What we do is, what we normally do, we multiply out. We do 5 times root 5 times 2 and root 5 times 7 root 5. Well, root 5 times 2 is just 2 root 5. And our second term is going to be root 5 times 7 root 5. Well, I'll write this down to start with, root 5, 7 root 5. We can rewrite this, though. We can, again, use this fact that we can reorder this multiplication, and we can write this as 7 root 5 root 5. Well, again, we know from our first rule, from the fundamental definition of what a square root is, that root of anything times root of that same thing gives us the original number without the square root. So root 5 times root 5, I know is going to give us 5. So this just becomes 7 times 5, which is just 35. And we end up with 2 root 5 plus 35 as our answer. Finally, rationalizing the denominator. Let's say we've got, let's say we've got 8 over root 2. Well, by rationalizing, what we mean is we want to get rid of this root sign. We don't want to have any roots in our denominator if we can avoid it. So what we're going to do is we're going to use a trick. We're going to use the exact same first rule. We're going to use the fact that we can take a root, times it by itself, and it will get rid of that root. We're going to do that same thing here. We're going to take this root 2, in this case, and we're going to times it by root 2. And obviously we have to times the top by root 2 as well to keep that whole value the same. What that gives us is 8 root 2 on the top over root 2 times root 2 on the bottom. And we know from our first rule and the definition of what a square root is, that this is the exact same as 8 root 2 over just 2. And we can simplify further. 8 over 2 is going to give us 4, so that's 4 root 2. And that'll be our final answer. Right, let's look at some exam style questions to finish off with. So let's do question 1. Write root 48 in the form k root 3. And so we know that we're going to have to use our third rule, right? We're going to have to write root 48 as something times something, a times b, in this square root. We've just got to figure out what a times b have to be. Well, I know that I've got a root 3 in my final answer, so I know that b has to be 3. Well, something times 3 has to give me 48. And if my multiplication is fine, that's going to give us 16. So that tells me that it's the exact same as 16 times 3 inside that square root. Well, I can use my second rule, which says I can split a multiplication, and this is the exact same as root 16 times root 3. We know root 16 is just 4, so we end up with 4 times root 3, and that's our answer. We get 4 root 3. Let's look at question 5. Expand and simplify. So we'll do the same thing we always do. We should get 4 terms. We'll do 2 times 2, first of all. We get 4. We do 2 times minus root 3. We get minus 2 root 3. We then do root 3 times 2, and we get plus 2 root 3. And we do root 3 times minus root 3. We get minus 3. Well, that and that are going to cancel out. They're just opposites to each other. We end up with just 4 minus 3, which gives us 1. So 1 is going to be our answer. Rationalize the denominator. This is very similar to what we just did on the previous page. So we're going to use this trick again, that the square root of 3 times the square root of 3 is going to cause the square root to vanish, right? We do the same thing to the top because we have to do the same thing to both the top and the bottom always. This then becomes 6 root 3 on the top, and root 3 times root 3 gives us just 3 on the bottom. 6 root 3 over 3 is going to give us just 2 root 3 as our final answer. And that is the end of Surds.